Okay. Now we are going to discuss about the transaction log file. Okay. So the thing is like as a DBA, we need to maintain the some proper techniques and maintenance activities and some other mechanism. Why? Because the thing is like if something goes wrong, okay, how we are going to recover the data. Okay. So that also fully depends for the transaction log file. So this transaction log file in the upcoming sessions, we have, we can change the behavior for the transaction log file, but what exactly the transaction log file will contain. So in the upcoming sessions, we can discuss about the this transaction log file behavior. Okay, like we can change the this particular behavior. But now before going for that, we need to understand the transaction log file, why it is important, and why the database must have that required. Okay, the thing is like the transaction log file is the critical component of the our SQL Server database. Why? Because whatever the data is going to modify that data, what will happen? Uh, what are the data is going to modify? That modified data will modify first in the what I meant to say, a buffer cache. Then it will modify the data in the transaction log file. And then finally it will go to the our database. Why? Because each and every time if you going to do modify and commit, what will happen? The data will be, our data file will go for the more disk IOPS, and we, there will be system always busy and system also will crash. So for that, what are the pages? The pages is not directly going to modify the our MDF file. Let me go for a diagram. Then we can discuss the, I think, database architecture. I will explain first. Instead of going for the transaction log file architecture, let me explain database architecture. This we can consider as a our system. Okay, it's a VM, it's a virtual computer or node we can consider. Okay, in that, this is a SQL instance. This we can consider as a database. Okay, so each and every database, what I mentioned, we have a EMDF and one LDF, right? So what I'm going to do, I'm going to keep like a, I'm imagine like a, this is one. Let me go here. This is the EMDF. I need some place. And this is the MDF. This is the ELDF. Okay. Let me take some buffer cache. Okay. So you can call like a database EMDF, ELDF. This is for buffer cache. So the thing is like we have a one SQL Server instance. Okay. In that we have a one database. Here we have one database or multiple database. Okay. Suppose let me take one more database as well. But I will give you the example for one database. So this is the one database. Okay. So each and every database having one MDF and one LDF, and this one also having one MDF, one LDF. But the buffer cache, what are the we have, that is shared for the our entire SQL server. So this shared buffer, this buffer cache is belongs to the entire uh, for the VM. Okay. So the thing is like this buffer cache we can limit to the our VM level to the SQL properties. Right now we have only think about like one SQL instance. In that we have multiple databases, and we can discuss about the how the data is retrieving, how the data is storing. So we have a buffer cache. So this buffer cache is belongs to the shared buffer pool for the our user databases. So now the thing is like the one user, like let me go for here. One user, the one user is you want to insert update the data. Okay. So initially like whenever the data is inserting, what will happen, the user will send the request to the SQL server. The SQL server take the request. Okay. So this kind of part of the SQL server architecture, but we have a full architecture SQL server, but this is the core component for the our SQL architecture as well. Okay. So now the thing is like we have a user, the user send the request. Okay. Once the user is send the request, the SQL server take the request, and using the request, it has a table or some other syntax, right? So whenever the people are inserting, updating, what will happen? The first the user look for the data in the EMDF. Okay. And the thing is like the SQL service is not directly allowing the modifications to the EMDF. So I want to insert the data or update the data on the database. SQL Server is not involving or allowing the any users to directly not do any modification on the database. Instead of what they will do, our SQL Server, what are the tables we have? That table which will bring the here. So the table means like initially the data stored in the record. The data, the record means where it is going to stored. It is going to stored in the page. So that means what are the data is going to modify. That page will come to the buffer cache. So the thing is like whenever the user wants to modify the data, the SQL Server is not directly allowing those modifications to the disk or MDF file. Instead of that, what will you do? The SQL Server, it will take that particular table information. Table information is like that particular page information. It will take and it will pick the putting into the buffer cache, and it will start modifications on the which particular page. So what are the modifications happening? Okay, those modifications information will writing simultaneously into the our LDF. So the thing is like initially whatever the data is going to modify, that modify data will pick from the disk. Disk means MDF or maybe ENDF. Why? Because our permanent data is stored in the data file. The data file may be MDF file or maybe ENDF file. So that is the reason the data will pick from the disk and it will keeping into the buffer cache. So that means what are the pages are is going to modify. That may be single page or multiple page. Why? Because sometimes based upon the user request, the page data has to modified or one page or multiple pages are extent. So that particular data will be putting into the our buffer cache. Once we put the buffer cache, the SQL server will start modifying the data, updating the data to the SQL server in the page. Then what are the modifications happening? That simultaneously it will start recording the that pages information to the MDF. So the kind of like a here statements. Those statements information which will record using LSN number. So what are the pairs are going to modified? Those statement information, our SQL server write the information to the transaction log file. Okay, those like a statements and what are the transactions is going to modify our pages using the statement. Each and every statement having the LSN number. This LSN number using the information, it will be stored the data in the LDF. And what will happen once the modifications are committed, then immediately those information also will putting into this page. So the thing is like I have got a transaction. That transaction is going to modify the particular table or page. Those page will pick from the disk and it will keep into the buffer cache. And those information simultaneously it will start recording into the ELDF. And thing is like it will do the modifications here. Once the commit happen, what will happen? Those commit will happen also here. So initially, what are the pace are happening or modification? Those transactions will recording into the LDF. So that time, what will happen? What are the transactions are coming from buffer cache to LDF? Those transactions will call like a active transaction. Why? Because that page came from MDF. It like a disk. It is going to it kept on the buffer cache. Those transaction information it's going to keep in the transaction log file. What are the transaction is kept initially? The transaction will like a active transaction. Why? Because those transaction information still is modifying in the buffer. Once the commit happen, immediately the commit also will happen in the LDF. So before commit, the transaction will stay act like a active transaction and ongoing transactions, and the data is not committed. Once the commit happen, once the commit happen from the like once the commit happen in the buffer cache, the simultaneously uh, commit also will happen in the transaction log file. Then once the transaction commit happen, what will happen? Then data will send to the here. So the thing is like here multiple things involved. We can go for discuss one by one. The thing is like the user send the request. Then what will happen? The user initially look for the buffer cache. Okay. And the buffer cache having the required data to modify. Okay. So the thing is like whenever the update insert is happening, the data should not be here always stored in the MDF. Why? Because the data is committed, right? So that is the reason it will interact here. It will interact here. Then it will go to here. Then it will pick the page. It will put the page here. Wait, come on. So it will look for the page and it will put the page here. It will do the modification start here. Once the transaction is right, the transaction, each and every transaction having the LSN number and some other information, right? Those information, it will start recording into the LAF. And once the data is modified or committed, immediately it will send the acknowledgement to the transaction log file. Data will be here also committed. Once the data is committed, the data will be moved from LDF to EMDF. Okay. So what is that means? The data is modified here. What? The data is not flushing from buffer cache to MDF. No, the data is going to move from LDF to EMDF. So this concept will be little bit different for the Postgres and Oracle. Why? Because in the Oracle and Postgres, what will happen? Once the commit happen, the data will be pushing from buffer cache to MDF. But in the LDF, like that SQL Server, what will happen? The committed data will push from the LDF to MDF. The data is not going to push from buffer cache to MDF. The data is going to LDF. The thing is like what are the transactions are coming to the MDF to buffer cache. So the thing is like it required some pages, right? So what are the page is sitting into the MDF? The initial page it has to pick it and it has to keep it here. Right? So what are the page it is going to pick and it is going to keep it here. Right? That place we can call like a clean place. So clean place is nothing but the page is not going to modify from the MDF. That page picked from the MDF and it is going to keep the buffer cache. That initial process, that page we can call like a clean place. So once the page kept here, the based upon the transaction, it has to update the data, right? So once the starting updating the data, the clean place can be like updated. So that update page we can call like a dirty page. So the dirty page is nothing but a after modification of the clean page we can call like a dirty page. So these dirty pages will be stored in the buffer cache and clean pages will be stored in the MDF. And what are the transactions are initially before commit keeping into the LDF, those transactions we can call like a active transactions. Once we committed, the committed data will be go to the here. So once we data is committed, the previous transaction uh, uh, will go for like a inactive portion on the LDF. So the thing is like whenever the transactions comes to the buffer cache, the transaction will move to the pushing into the LDF. Those transactions we call like a active portion of the LDF. That is called like a active transaction. Once the active transaction committed in the buffer cache, the parallelly the data will be committed here. That committed transaction, the data will moving from LDF to MDF, and what are the portion allocated in the LDF? That can portion we can call like a inactive portion, and the committed data will be moving here. So the thing is like here one more concept we'll call like a wall. So wall is nothing but a what are the data is going to keeping into the like writing into the MDF, that data will be writing into the LDF. So that concept we can call like a wall. Write head logging. So what are the transactions before writing into the data file? The data will be recording into the transaction log file. That recording into the transaction log file we can call like a wall. So wall is nothing but a what are the modified, like what are the updated data recording into the LDF before going to the MDF, that storing into the LDF concept we can call like a wall. Okay, so wall is simple definition, nothing but a what are the transactions are before going to the data file. The transaction will be recording into the LDF. This concept we can call like a wall. And here two things are involved. Okay, so why? Because who is going to moving the data from LDF to EMDF? So here what I mentioned, the data is once the data is committed here, the transaction will be committed here also here. And who is moving the data from LDF to MDF? So who is going to move the MDF to LDF? So the moving the data will from the checkpoint. So in the SQL Server, little bit confusion from the checkpoint and lazy writer. We are going to clarify here. Okay. So checkpoint. CHACK checkpoint. So the checkpoint is a internal mechanism or operations that will synchronize the data between from the LDF and MDF. The checkpoint will occur whenever you run the commit or whenever you run the alter command and whenever you uh, perform the manual checkpoint. That time what will happen? What are the committed data? That committed data will move from EMDF to ELDF. Okay, so there will be checkpoint interval that will be run regular interval, or else we can run the manual checkpoint as well. So checkpoints are two types. One is manual checkpoint and one is a regular checkpoint. And checkpoint also will run whenever you run the alter command or whenever you run the backup command, and whenever you go for the kind of a restart or whenever you go for the database offline and online. That time internally SQL Server will operate the one process is called a checkpoint. Checkpoint is a background internal mechanism process that will synchronize the data between from LDF to MDF, and checkpoint will move the data from the transaction log file to MDF, but the checkpoint which will move the data only committed data from the LDF, and inactive uncommitted data will be keeping into the LDF. Why? Because the thing is like what I mentioned, checkpoint will occur whenever you're going for restart or whenever you're going for offline database, right? So whenever you're going for restart, what will happen? Suppose the data is starting moving here from LDF to MDF, the database got restarted. Once the server is up, what will happen? The SQL server, it will check again LDF and it will start reading the data from the LDF, and it will scan the entire transaction log file, and it will check what are the complete transaction that will pushing into the MDF and what are the uncompleted transaction that will be keeping into the LDF. So that is the reason what will happen whenever the SQL Server restart our database offline, we can see the states called like a database recovery pending or pending recovery. So internally what will happen? The SQL Server check in the background what are the committed or what are the uncommitted. The committed data will be moving it to the MDF and uncommitted putting it to the LDF. Uncommitted means like it's kind of like a that may be failed transaction or that may be ongoing transaction. Why the fail? Why the fail means like that the transaction came and it keeping into the buffer cache and keeping into the LDF. In between, system got crashed or restarted. So what are the transactions are running? That process got discounted, right? So what are the statements are executing? That will go to fail state. So that is the reason the checkpoint, it will scan the transaction log file and it will move the committed data from LDF to EMDF. But the checkpoint won't clear the space on the transaction log file. These things we have to remember. Why? Because the checkpoint is not going to clear the space on the LDF. Here, why the space occurred? The thing is like if you going to recording the data from buffer cache to LDF, what will happen? What are the pages we have in the buffer cache after restart? This page will be gone. Okay, but what are the data previous recording or modification? Those stored be in the LDF. So LDF means the LDF is a physical like a initial topic. The LDF is a file, right? The LDF is a store the data in the physical file. So that means what are the data we are going to keep that physical file will be stored in the LDF itself. It is not going to clear checkpoint. It is not going to clear any data which is stored in the LDF. But what will happen? It will push the committed data to the MDF. Okay, it is not going to clear the space. This space clear we can discuss in the topic of the like backups. So the clear cut definition of the checkpoint: the checkpoint is a one of the background process. It is a SQL Server internal mechanism. The checkpoint scan the transaction log file, and it will push the complete transaction from transaction log file to MDF, and it will synchronize the data between MDF and LDF. Synchronizing means like what are the committed, it should not be keeping in the LDF. Those transactions it has to moving it to the MDF, like a synchronization. That is called like a ELDF, like a checkpoint. So the thing is like now we can go for one more scenario, like we have a data more pages queue. Here more pages queue. Here more pages queue. So the thing is like buffer cache having uh, the transact user is sending the record, and it is picking the disk and it is keeping it to the buffer cache, and the parallel it is keeping it to the LDF. So the thing is like we have a more request or more users are sending the request. So that required more page rate. What will happen? The in the background, the SQL server it will take page from the MDF and it will keep on putting into the buffer cache, and it will start modifications. Once the commit happen, the dirty page will be keep it here only as a committed and committed, and one more user transaction came. That user transaction required one more page. So it is going to keep in the buffer cache. Why? Because this page has to modified to as per the user request, but it's trying to keep the page in the buffer cache. So that time what will happen, that we don't have space on the our buffer cache to keep it. So the user transaction will go for like what I meant to say, it won't execute right. Why? Because if you want to modify the data, the page has to come to the buffer cache. From there, it has to modify it. The parallel, it has to send the LF, it has to move it. But in the initial process itself, it's failed because we don't have uh, storage to keep in the buffer cache. So that time, what will happen? In the we have a one more background process. We have a one more background process. One more background process. Lazy writer. So whenever the new page is going to keep in the buffer cache, that buffer cache we don't have space to keep in the uh, new page. At that time, what will happen? Lazy writer, it will scan the entire pages in the buffer cache. Okay, the lazy writer is the also background process in the SQL Server. It will scan the buffer cache on the system. What it will do, it will find out the what are the pages are not required, what are the pages are not modified in the past. So that means we have 100 pages. In that 100 pages, what are the pages is not going to modified from the past, and what are the pages are not required. It will identify it, and it will move the, it will flush the memory pages from the memory. So that means what are the pages are is not going to modified, that will be take out from the buffer cache, and the space will be allocated for the new page. So simply lazy writer is a internal mechanism. It will scan the buffer cache, and it will go for the one algorithm. Why? Because it has to know right how which page is going to modified, how long, and when it is modified is going to really used or not. So using the lazy writer, in the background, it will go for one mechanism. That mechanism, 1 minute, mechanism. So that mechanism we can call like a LRU algorithm, last recent used. So using the last recent used, and which page is last recent used, that is not going to require. That page will take it from the buffer cache. Like taking out, we can call like a flush. It will take the that page from the flush from the buffer, and it will get the new page. So the lazy writer, it will run work on the buffer cache. Checkpoint, it will work on the our LDF. So the interview, the question will ask, can we get the difference between checkpoint and a lazy writer? And when is going to checkpoint run and when is going to lazy writer? So the lazy render, it will run the buffer cache in the regular interval, and it will check if you have any page is not going to modified or in the longer time, it is not going to require that time. It will fetch and it will allocate the play storage for upcoming thing. The thing is like if the lazy writer is going to keep on scanning and keep on writing, that means we have some memory issue. So when we going for memory issue topic, then the lazy writer, how it's going to look for the one parameter value. By looking the lazy parameter value, will come to know in the our SQL Server system do you have memory pressure or not. So the lazy writer using the parameter, we can conclude is one parameter like we have a memory pressure. Why? Because whenever we running the lazy writer, we can see like some flushes from the buffer cache. Those the information will recording into the our SQL Server log. Okay, so we can see that like we can run the flushes using the command as well. So no need to go for lazy writer. Sometimes we can run the dbgc free pro cache. So means we are going to clear the cache from the pages. That will eliminate the our pages and some execution plans from the buffer cache that will release the space. So, but the thing is like lazy writer is for job is to remove the pages from the buffer cache which is not going to modified. So this is the how the data is retrieving, how the data is moving to the from LDF to MDF, and what is the wall concept, and what is the checkpoint, and what is the lazy writer. So here three interview questions. One is the wall, and one is the checkpoint, and one is the lazy writer. These are the very important concept. Definitely they will ask for the definition and as well as the difference, and wall concept they will ask. Okay. So I hope you understand for the checkpoint and lazy writer and wall. Now we can move into the transaction log file architecture. In the transaction log file architecture, we are going to discuss the same topic we discussed at LDF, virtual log, what I meant to say, committed portion and active, inactive portion. That those transact side we can discuss. And apart from that, we are going to discuss one more key topics, how the transaction log file will be cleared, because the LDF committed data is going to move from LDF to MDF using the checkpoint, but actual the storage will be remains and the LDF. That storage who is going to take care for upcoming transactions. Why? Because the thing is like the lazy writer flushing from the lazy writer. Okay. But the what are the storage we are going to keep that will be stay right. So the pays are coming and keeping here. Pays are coming here and keeping here. So that required also some storage right. Who is going to truncate the complete portion? That we are going to discuss in the log file architecture. So let me stop the recording. Then we'll go for the log file architecture. Let me stop it.